Today we're going to do the video notes for lesson 5-5, and that begins on page 295. So we're going to start talking about factors and multiples. I can find the greatest common factor and least common multiple of two whole numbers. And the vocabulary we're going to look at this week, or in this lesson, would be common factor, greatest common factor, and least common multiple. Another way we also talk about this, we give it the initials GCF or LCM. So those are the two things you might see also. So greatest common factor, we just use the first letters of each of those words. And then LCM, least common multiple, would be LCM. Learn greatest common factor. A common factor is a number that is a factor of two or more numbers. The greatest common factor of two or more numbers is the greatest common factor, GCF. So we're looking at factors. Remember, those are the numbers that you multiply together to get that number. You can find GCF of two or more numbers using different methods. Some of the methods include listing the factors or making a factor tree. You might have done listing the factors in the previous grades, and I'm going to show you how to do a factor tree. So in the animation, which you'll see later, the animation shows the list of factors of each number used to find the greatest common factor, 9, 15, and 8. So the factors, we can make a list. Factors of 9 would be 1, 3, and 9. So 1 times 9 is 9. 3 times 3 is 9. Factors of 15, 1, 3, 5, and 15. So 1 times 15 is 15. 3 times 5 is 15. Factors of 18, 1, 2, 3, 6, 9, and 18. So 1 and 18, 2 and 9, 3 and 6. The common factors are 1 and 3. So if I take a look at this, I'm looking for common factors. So those are the numbers that appear in each of those lists. So we have 1 and we have 3. I always try to circle them and group them, and it helps me visualize the common factors with the numbers we're looking for. Since 3 is greater than 1, the greatest common factor would be 3 in this case. When is making a list of factors difficult to do? Well, one way it would be difficult if there's too many factors. Here in 9, 15, and 18, we have 6 of them. And that's okay. We can write out the 6, but if we get beyond that and going into 10, 12, 14 different factors, then we have an issue, and this issue would be the list would be too long. Continuing on to page 296, at the top of 296, we have example 1. Find the GCF, or greatest common factor, by using a list of factors. Use a list of factors to find the greatest common factor of 12 and 28. So in this case, we're going to list the factors, and we're going to find the factors of 12 and 28. So we need to start thinking about what numbers multiplied together equal 12. So I'm going to start my list. So factors of 12 would be 1 times 12, 2 times 6, 3 times 4. Factors of 28 would be 1 times 28, 2 times 14, or 4 times 7. I also do it this way too. I make a T-chart, and I put 12 at the top, and I say 1 and 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And 28, I would do the same thing. 1 and 28, 2 and 14, 4 and 7. And then I would go and I would identify the common factor. So you can do that either here in the T-chart or in the list, 1 is a common factor, 2 is a common factor, and 4. And you can see that here. We have 1s, we have 2s, and we have 4s. So identify the common factor. The common factor is 1, 2, and 4. Identify the greatest, so that means the largest one of those three, 1, 2, and 4, 4 being the largest. So the greatest common factor of 12 and 28 is 4. Check. List the factors. Use a list. Sorry about that. Use a list of factors to find the greatest common factor of 9. So 9 would be 1, 3, 9. 1 times 9 is 9. 3 times 3 is 9. 20. 1 and 20. And this is where I like to do my T-chart. So I have 1 and 20, 2 and 10, 4 and 5. So I would say 1, 2, 4, 5, 10, and 20. So 1 and 20, 2 and 10, 4 and 5. And as I take a look at that, I have to then identify the common factors. And as I look at this, I identify 1 as being the only number that's the same in both lists. So my greatest common factor of 9 and 20 would be 1. So like I said, you can make the list, or another way, like I said, you could do a T-chart, 1 and 9, 3 and 3. And 1 would be the only number that's common between the two. Example 2. Use a factor tree to find the greatest common factor of 52 and 78. Now, remember back on the other page, we said, when would a list not be good? This would be the case because sometimes there's a number of factors, and in this case, we can go ahead and use a factor tree. So for greater numbers, listing all the factors can be inefficient. It means not the best or quickest way to do it. A factor tree is another method you can use to find greatest common factor. Complete each factor tree. So 52. We have 52, and what we do is we take this 52 and we look and see, okay, what two factors multiplied together equal 52? And we have 2 times 26 equals 52. 2 times 26 equals 52. And then I look at this, can 2 go any smaller? No, it can't. So 2, I'm going to leave 2 here. But 26, I can break it down because there's other factors. So what are two numbers that can be used to show as factors of 26? And in this case, we can do 2 and 13 because we know 2 times 13 equals 26. Let's do the same thing for 78. So what two numbers or factors do you multiply together to get 78? 2 times 39 equals 78. 2 times 39 equals 78. 2 does not have any other factors that we can use, so 2 would stay the same. 39, though, we can take, they have a 13 here, so something times 13, and in this case, we would say 3 times 13 equals 39. I'm going to continue on to the top of the next page, 297. So if I look at the bottom row, and let me do this here. If I look at the bottom row, I'm just continuing from the page above. So here's my bottom row. Let me adjust this a little bit. So here it says, look at the bottom row of the factor tree. So here's our bottom row of the factor tree. We have 2 times 2 times 13 equals 52. We have 2 times 3 times 13 equals 78. If you look at the bottom row, the common prime factors are So what's the same? So if we take a look here, all of these numbers here, 2, 13, 2, 3, 13, those are all prime numbers or prime factors. So using a factor tree, we should when we factor it out, these last numbers need to be prime numbers. You cannot break them down into smaller factors. So if I take a look here, they're asking for common prime factors that are in both of these. So I would say we would have 2's. There's a 2 in each. So we would say 2 is the same. And then 13 and 13. So 2 and 13 are common in each of those numbers. Now, because 2 and 13 are factors of both 52 and 13, the product of 2 and 13 is also the factor of both numbers. So that seems a little strange, but what they're saying is when you find the prime numbers that are common in both numbers, you can take those two numbers and you can multiply them together to come up with the greatest common factor. So multiplying 2 and 13, we would come up with 26, and that would be the greatest common factor of 52 and 78. Let's go ahead and let's do factor trees for 45 and 75. All right, so we have 45. I always look at this, and if it ends in 5, I'm going to put a 5 there, and I'm going to say 45 divided by 5 is 9. 5 is a prime number, so 5 stays. I always like to circle it when I'm in a prime number, so I know I'm done. 9 is not prime. Even though it's an odd number, it is not prime. And I can take and break that down into factors of 3 and 3. 3 times 3 is 9. I know 3 is prime, so I'm going to circle both of those. So 5 times 3 times 3 equals 45. Now let's do 75. So it ends in a 5, so I'm going to use a 5. So 75 divided by 5 gives us a factor of 15. So 5 times 15 is 75. 5 is prime. I'm going to circle it. 15 is not prime. I'm going to go ahead and break that down into factors. 15 is 3 times 5. And both of those are prime numbers. So if I'm taking a look at this, I can say 5 times 3 times 5 equals 75. And 5 times 3 times 3 equals 45. So what they said in the previous example was look at this bottom row. So I can bring this 5 down because it is prime. So I have 5, 3, and 3, 5, 3, and 5. So the numbers that are the same in each would be 5 and 3. Whoops, I almost put a 5 again. 5 and 3. Because I have a 5 here and a 5 here, a 3 here, and a 3 here. So 5 times 3 is 15. 15 is the greatest common factor of 45 and 75. Continuing on to page 298. At the top, learn least common multiple. All right, so we just did greatest common factor. Now we're going to look at least common multiple. So multiples, remember multiples are like skip counting or counting by 5s or counting by 2s. There's a number of ways to describe that. So least common multiple would be the smallest of those numbers. Let's see. The least non-zero number that is a multiple of 2 or more whole numbers is called least common multiple, LCM, of the numbers. You can find the least common multiple of a set of whole numbers by listing the multiples or using a number line. Here we go. So the multiples of 4 would be 4, 8, 12, 16, 20, 24. And the multiples of 6 would be 6, 12, 18, 24, 30, 36. So if I take a look at this, we're just counting by 4s, we're counting by 6s. And we're looking for common multiples. That means multiples that show up in both lists. So I have a 4. I'm sorry, I don't need the 4 there. Let me erase that. So 12 shows up in the 4 list and 6 list, and 24 shows up in the 4 list and 6 list. So I have 12 and 24. So the common multiples would be 12 and 24. We could go on and we could find more common multiples, but at this point we want to find the least or the smallest. So 12, since 12 is less than 24, the least common multiple would be 12. So one way to do it is to list, but that sometimes can be hard. So we can also do this. If you have a number line, you could go ahead and you can represent the multiples of 4 with an X. You can multiply and then represent the multiples of 6 with a dot. And you can see where they line up or where they land on the same. So both X and there's a dot would be 12. X and a dot would be 24. So the smallest or the least common multiple would be 12 because it's closer to 0. Example 3. List the least common multiple by using a list of multiples. So here is the example. Ernesto is at a community center every 8 weeks for his painting class. Camilla is at the community center every 6 weeks for her pottery class. So we have 8 weeks, we have 6 weeks. They are both at the center for their classes this week. So they're both there this week. How many weeks will it be until both have their classes in the same week again? So we could go ahead and we could say here the multiples of 8 would be 8, 16, 24, 32, 40, 48, 56, 64, and so on. Multiples of 6 would be 6, 12, 18, 24, 30, 36, 42, 48, and so on. So those are the list of the multiples. So if we take a look at this, let's look at the next step, which would be step 2 at the top of page 299. It says identify the least common multiples. So if I'm taking a look at this, they've typed them out for us. Circle the multiples that are 6 and 8 that are in common. So if I take a look at this, I could say here's 24 and 48. Those are the multiples that are the same for the list of multiples of 8 and the multiples of 6. We're looking for the least or the smallest of those, and that would be 24. So when Ernesto and Camilla have their classes on the same week again in 24 weeks. Every 10th week, Tamika visits a zoo. So this is 10th week. Every 12th week, she visits the local pet rescue. If she visits both this week, how many weeks until it will be where she visits both the same again? All right, so let's do 10 and 12. So we have 10, 20, 30, 40, 50, 60, 70. For 12, we have 12, 24, 36, 48, 60, 72, and so on. So if I'm taking a look at these, I can find the common multiples. So I'm looking for numbers that are the same in each. Oh, I find 60 is common in both, and that there's nothing less than that. So the least common multiple would be 60 weeks. So they would see each other again, or she would visit both in 60 weeks. Continuing on page 300. So the other thing we can do is we can take a look and we can find the least common multiple by using a number line. So use a number line to find the least common multiple of 2 and 3. So what I'm going to do, I'm going to put an X above every multiple of 2. So 2, 4, 6, 8, 10, 12. And then I'm going to put a dot above each multiple of 3. So 3, 6, 9, 12. So if I take a look here, I see that 6 and 12 have both an X and a dot. So we would know that 6 and 12 are common multiples of 2 and 3, but we're looking for the least common multiple that would have a dot and an X above it, and that would be 6. So the least common multiple of 2 and 3 would be 6. Now let's practice using the number line. Use a number line to find the least common multiple of 2 and 8. So I'm going to put X's above multiples of 2, dots above multiples of 8. So I'm going to do 2, 4, 6, 8, 10, 12. And then I'm going to put dots above multiples of 8. So 8, there's no 16. So 8 would be the least common multiple, would be 8.